Good day everyone, I'm Sarah Midi Alicante from Section Gold. So today we will discuss about atomic model and quantum mechanical model of atom. So please watch this. So first of all, let me ask, what is this atomic model mean? So, in atomic model, most matter consists of an agglomeration of molecules, which can be separatedly relatively easily. Molecules, in turn, are composed of atoms joined by chemical bonds that are more difficult to break. Each individual atom consists of smaller particles, namely electrons and nuclei.
Each atom has a dense center called a nucleus. The nucleus contains neutrons, which have a neutral electric charge, and protons, which are positively charged. The number of protons in an atom determines an element's physical properties. No two elements have the same number of protons. Revolving around the nucleus like planets around the sun are negatively charged particles called electrons. Electrons and protons attract each other, so atoms usually have equal numbers of the two particles.
Erwin Schrödinger proposed the quantum mechanical model of the atom, which treats electrons as matter waves. An atomic orbital is defined as the region within an atom that encloses where the electron is likely to be 90% of the time.
Rayleigh, Schrödinger, and Heisenberg arrived with the idea that the quantum mechanical model of the atom describes the probable location of electrons within the atom using atomic orbitals. As you can see in the animation, there are different kinds of atomic orbitals that differ in the amount of energy and shapes where the electron probably is. The quantum mechanical model describes the region of space around the nucleus as consisting of shells. These shells are also called principal energy levels. Electrons closer to the nucleus are at a lower energy level and have lower energy than those farther away from the nucleus.
Then the next question is Dalton's model. First, let me just state what Dalton said. Number 1. Stuff can be broken into elements, the things listed in the periodical table. Number 2. The elements are atoms with different masses. Number 3. Compounds are combinations of elements, like water, salt, or pizza. Basically, Dalton just expanded on the Greek idea of the atom. An atom is a small thing, and there are different masses with different properties.
John Dalton proposed that atom was indivisible and indestructible, but this can only be said so if it is not composed of further particles. Are there particles that are smaller than an atom? Sure, there are. The discovery of the fundamental particles, protons, neutrons, and electrons inside the atom led to the failure of Dalton's atomic theory. This also proved void Democritus's and Canada's theories that atom is indestructible.
The next one is Jameson Thomson. Thomson played with cathode rays. These are just beams of electrons. But cathode rays sounds cooler. By having the beam interact with electric and magnetic fields, Thomson was able to determine the mass to charge ratio for an electron. So, from that he know that the electron came from the atom. It had a negative charge and a small mass. Here is the model that he proposed.
Who were the people behind the discoveries of these particles? They were none other than James Chadwick, who discovered neutron, Eugen Goldstein, who discovered proton, and J.J. Thomson, who discovered the electron. So how do we explain the arrangement of protons and electrons inside an atom? To explain the arrangement of protons and electrons inside the atom, J.J. Thomson prepared a model for the structure of the atom, known as Thomson's model of atom. The model of an atom proposed by Thomson is similar to a Christmas pudding. In this model, Electrons are arranged in a sphere of positive charge like plum in the spherical Christmas pudding. So it is called plum pudding model of an atom.
And of course, there he is, Rutherford. Ernest Rutherford said one day, "Hey, I think I will shoot some stuff at atoms." I am sure his wife said, "Oh, Ernie, if it makes you happy to play with your little physics stuff, go ahead. I know how much you like it." So he did. He shot some alpha particles, which are really just the nucleus of a helium atom, at some really thin gold foil. Here is a diagram of his experiment.
Structure of an atom and study it again. Around the year 1911, a British physicist, Ernest Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom. The experiment was carried out by Rutherford along with Hans Geiger and Ernest Marsden. The experiment he performed was a breakthrough in the field of chemistry, which helped him understand the structure of an atom in a more accurate manner. This is how the setup of his
Bohr model. The model proposed by Niels Bohr is the one that you will see in a lot of introductory science text. There are a lot of good ideas in this model, but it is not the one that agrees with all of the current evidence. The model tries to make a connection between light and atoms.
in our list called Niels Bohr. He made a few additional explanations to describe the atomic structure. The postulates put forward by Niels Bohr were as follows. Firstly, only certain special orbits called discrete orbits of electrons are allowed inside the atom. Secondly, while revolving in these discrete orbits, the electrons do not radiate energy. Now these points definitely tell us why an atom is so stable.
Schrödinger and Heisenberg model. There is a key point about the Bohr model that is no longer accepted in current models of the atom. In the Bohr model, the electrons are still thought to orbit the nucleus just like the planets orbit the sun. Actually, this is something that we cannot say is true. The problems with atoms and electrons is that we humans accept them to obey the same rules as things like baseball and planets. Actually, the rules are the same, but baseball and planets follow the rules of quantum mechanics without us humans even noticing. It turns out that we can't really say anything about the trajectory or position and electrons in an atom. What we can say is all about probabilities. We can say that what regions an electron is likely to be. Here is a diagram that might help. There are probability distributions for the different energy levels in an atom.